Welcome to the next part. Now we are discussing the energy level diagram for the hydrogen atom. The energy level diagram of hydrogen atom, it shows the various stationary states of the energy of the various stationary states of an atom, which are represented by a set of horizontal parallel lines which are drawn according to a suitable scale. We know that energy of an electron in any nth orbit is given by En is equal to minus 2 pi square m k square z square e raised to power 4 divided by n square h square. For hydrogen atom z is equal to 1. So if we substitute values of all the constant factors over here and convert that energy into electron volt, we will get the final expression En equal to minus 13.6 over n square electron volt. That is, energy of an electron in any nth orbit is minus 13.6 divided by n square, with n ranging from 1 to 3 4 5. So in this equation, if we substitute the value of n as 1 2 3 4 so on, we get the value of the various energy level. So if n is equal to 1, the value of E1 will be equal to minus 13.6 electron volt. For n equal to 2, second level energy will be minus 1.51 electron volt. If n is equal to 3, energy in the third level, it will be minus 0.85 electron volt. If n is equal to 4, energy in the fourth level, it will be minus 0.85 electron volt. And if n is equal to 5, energy in the fifth level, it will be minus 0.54 electron volt, and so on. So when we move from first to the second orbit, the energy jumps from minus 13.6 to immediately minus 3.4 electron volt. That means the values in between minus 13.6 and minus 3.4, they are not physically possible. This means that energy of electron around the nucleus is also quantized. So this energy variation for the various orbits, it can be shown in this energy level diagram, which along with the transition for the various spectral series. From here you can see that in the first and the second level, there is a large energy difference between the two, and this energy difference can be obtained by subtracting the energy of the first and the energy of the second level, which is 10.2 electron volt. But if we take a look at levels 2 and level 3, the corresponding energy difference is now decreased. This energy difference between third and fourth level is again more or less, and as we move for higher and higher level, the energy difference between the any two consecutive level goes on decreasing, which shows that inner orbits around the nucleus of hydrogen atom, they are widely spaced, while the outer orbits, they are closely spaced with respect to each other. Although Bohr was able to explain the spectral series stability of the atom, there were shortcomings associated with the Bohr's theory also. For example, this theory is applicable only to the hydrogen atom or hydrogen-like atoms. That means atoms which contain only one electron. But it is failing for multi-electron atoms, atoms with two or more electrons. In hydrogen spectrum, certain spectral lines are not single, but they are grouped closely spaced line with slightly different frequencies, which are called fine spectrum. This means that if any spectral line in the hydrogen atom, it is observed with a powerful microscope, then that single spectral line is actually not one spectral line, but it is consists of a series of different spectral lines which are present very close to each other. We call this type of spectra as fine spectra. Why this spectra is existing, Bohr's theory cannot explain. The Bohr's theory is applicable for circular orbits, whereas in actual practice they are elliptical in nature. According to de Broglie, electrons are also showing the wave nature. So when wave nature is there, we cannot define the orbits will with 100% accuracy. So orbits cannot be defined exactly when electrons show wave nature also. In the spectrum of hydrogen atom, different spectral lines are of different intensities. Some are less intense, some are more intense. Why this is the case? Bohr's theory cannot explain. It can also not explain the Stark effect and Zeeman effect. Stark effect means when electric field is applied on the specimen for which we are taking the spectrum, under the effect of spectral electric field, the spectral line starts splitting up. This is Stark effect. But if we apply magnetic field, again splitting of the spectral line takes place. We call this as the Zeeman effect. So these were the few of the shortcomings of the Bohr's theory of a hydrogen atom. Last, we are discussing excitation energy. Excitation means sending an electron from any lower orbit to the higher orbit. So any energy which is required to send an electron for this purpose from the ground state or any lower orbit to any higher orbit, we call this as the excitation energy. For example, if we calculate first excitation energy, in which we send an electron from first level to the second level, in this case this will be equal to E2 minus E1, which will be equal to minus 3.4 minus 13.6, which will be equal to 10.2 electron volt. Second excitation energy, when electron is sent from first to the third level, it will be equal to E3 minus E1, which is equal to minus 1.51 minus 13.6, which is equal to 12.09 electron volt. Excitation potential, how much accelerating voltage should be applied on the specimen of the hydrogen atom so that they can be sent from a lower orbit to the higher orbit, that is called a corresponding excitation potential. We know that the first excitation energy is 10.2 electron volt. So we can directly write down the corresponding excitation potential, which will be equal to 10.2 volt. Second excitation potential will be, second excitation energy is 12.09 electron volt. From here we can write its value directly as 12.09 volt. Last, ionization energy. Ionization means removing an electron completely from the atom, completely freeing it from the attractive pull of the nucleus. That means we are sending electron from first orbit from the ground state to n equal to infinity. So ionization energy over here, it is equal to energy of the infinite orbit minus energy of the first orbit, which is equal to 0 minus 13.6, which is 13.6 electron volt, and corresponding ionization potential is 13.6 volt. So this is the hydrogen atom theory along with its limitation and definition and excitation and ionization potential. Thank you.